Hi everybody, and welcome to question number 47 on the SAT math list here on Wagner Academy. It says the figure is not drawn to scale, and in the figure above, the area of triangle WXZ is 25 and the area of triangle XYZ is 16. Let's label that as we go here. So WXZ, the area of that is 25, and the area of, again, XYZ, that's this smaller triangle right here, is 16. What is the ratio of the length of WZ, so this base, you could say, for this triangle, and the length of ZY, the base of this triangle right here? So we're trying to find the ratio, find the fraction of this length compared to that length. So from there, we can think of the area of any triangle is going to be 1/2 base times height. Now notice that the height for both of these triangles is exactly the same. If I think of the height being this perpendicular distance right here. So the height of triangle WXZ perpendicularly is this same thing right here. And so if I have that in mind, I can say that the area of, I'm going to call this the one I have in red here, WXZ. I'm going to do my work for that with red for right now. The area of that triangle is 1/2 base times height. Any triangle is 1/2 base times height. I know the area. I know it's 25. The base is WZ, so I'm going to use WZ instead of B. And the height, I don't know, but the height here is going to be the same as the height here for the blue triangle. So in a similar fashion, I can say, again, area of any triangle, 1/2 base times height. The area of the blue triangle of triangle XYZ is 16. And I've got the base, in this case, is ZY. And the height, don't know, but this H is exactly the same as this H. That will prove to be helpful as we go through this problem. You'll notice with a lot of these SAT questions, the math part of the problem isn't that hard. It's just kind of tricky to think about how to set it up sometimes. And so from here, we can determine what WZ is in terms of H, or what H is in terms of WZ. We'll see what's more beneficial as we go through this problem. If I multiply both sides of this equation by 2, I could get rid of that 1/2. I can say 50 equals 1/2. What did I just say? I got rid of the 1/2. There we go. Equals WZ times H. Now you might have looked at this right here before I did that step, and looked at this right here and known what it was already, because ZY is the only thing changing compared to WZ over here. So you might have an inkling as to what this is. We'll see if your inkling is right as we continue and progress through this problem. So if I wanted to say what H was in terms of WZ, I could divide both sides by WZ and say that 50 divided by WZ equals H. In a like manner, over here, can multiply both sides by 2. I'd have 32 equals, the 1/2 would cancel with the 2, equals ZY times H. And if I divided both sides by ZY, I'd have 32 divided by ZY. ZY would cancel, equals H. Remember what we said about the H here and here. The H here is the same as the H here. It's not a different height in either question. It's the same thing. So I'm going to bring these both together and think about what that would mean. So I've got H here and here. That means I can set this equal to this. So that would have to be true because the H's are exactly the same. So substitution says I can say that now 50 divided by WZ would have to equal 32 divided by ZY. And that would imply means extremes property says you can replace these two, or you can flip-flop these two. You can flip-flop these two. If you cross-multiplied and divided, you would find the same thing. It would just take a little bit longer, more steps. We're trying to find the length of WZ compared to ZY. So ratio of those two, if I had WZ on the top and divided by ZY on the bottom, that would give that to me. So I've got 50 over 32 would equal WZ over ZY. I just flip-flop places with these two right there. So from there, I can reduce this fraction. That would be divided by 2, both parts, 25 over 16 equals WZ over ZY. There's my ratio of WZ to ZY. A ratio is just a fraction. It's just one thing compared to another thing here. So this one, final answer should be choice E. For a little further explanation, or going back to what I talked about here, this equation right here and here, the only way for this to work out would be as if this ratio held up. This ratio is actually true. Doesn't matter what H is, it's going to be the same in both of these. It could be 1, it could be 2, it could be whatever, but the ratio of WZ compared to ZY, whatever H was, would have to be in this ratio. Would have to be 25 to 16 for this equation to hold up. It could be 50 to 32. It could be 75 to 48. That would be 3 times bigger than this. But that same ratio would have to hold. So some of you may have looked at the problem here and said, hey, I know the answer. I got this already. But just to show you that it actually worked out if we used substitution, went all the way with it. The ratio, 25 over 16. So choice E, either way you think about it.